We will do a problem in kinetics in which two blocks A and B of weight 150 Newton and 100 Newton are released simultaneously from rest on a 30-degree inclined plane when they are 15 meters apart. So initially they were 15 meters apart. The coefficient of friction between the plane and the block A is 0.2 and that between B and the plane is 0.4. Find the acceleration of each block. Also, in what time block A will hit block B. Okay, so two blocks are there. One is 15 meters apart from the other, and both of them are placed on an inclined plane, which is that at an angle of 30 degree with the horizontal, and they are released simultaneously. Then both of them will be sliding down the plane, and we have to find out the acceleration of each block. Also, we have to see in what time block A will hit block B. Okay, so how to solve this question? To solve this question, first of all, we have to draw a free body diagram. To draw a free body diagram, in this problem, two objects are involved simultaneously, or two objects are moving simultaneously in this problem, isn't it? If more than one object is there, we should consider each object separately and apply the corresponding equations and form the equations. Then we will solve simultaneously the formed equations and we can easily get the solution. So in this problem, so this is the given problem. I will draw as a figure. Say block B, block A, block B, WB is weight of block B is equal to 100 Newton, WA equal to 150 Newton, and mu B equal to 0.4, mu A is equal to 0.2, that is the coefficient of friction between block B and the plane is 0.4 and that between block A and the plane is 0.2, and they were 15 meters apart also. So this is 15 meters. Okay, and this angle is given as 30 degree. And these are released simultaneously. At the same time they are released. So both the blocks will be sliding down the plane, and the block B, say suppose when the block B reaches here, block A also reaches the same point, so that there will be a collision. We need to get the time of travel of say any one of them. We need to get the acceleration of the blocks also just before hitting. Okay, so when a number of objects are involved, what we have to do is we should consider each of the objects separately. So here, first of all, let us consider the block A. So block A is here. Its weight is acting through the center of gravity 150. The normal reaction perpendicular to the inclined plane. Okay. Then force of friction in the upward direction. It is 0.2 into Ra, because 0.2 is the coefficient of friction. And we know the two components of weight. Component of weight will be, what will be the value? This parallel component will be sine component. So this, as this angle is 30 degree, the sine component will be 150 sine 30, and this component will be 150 cos 30. 150 sine 30 and 150 cos 30. Okay, so these are the forces acting on the block A while it is moving down. It is 150 sine 30. 150 sine 30 and 150 cos 30. Okay, so for block A, consider the forces perpendicular to the plane first. Perpendicular to the plane. What are the forces perpendicular to the plane? 150 cos 30 and Ra. So sigma F equal to 0 in this case, because it is not moving in the perpendicular direction. So there is equilibrium. So we can apply static equilibrium equation perpendicular to the plane. Okay, sigma F equal to 0. Then sigma F is Ra minus 150 cos 30 equal to 0, or this will give you Ra equal to 150 cos 30. So it is 129.9 Newton. 129.9 Newton is Ra. Then now we consider forces acting on body A parallel to the plane. Here sigma F equal to ma. It is not equal to 0 because it is moving. There is net force. So if there is a net force, the body should have an acceleration, and sigma F equal to ma according to Newton's second law of motion. Or even you can apply sigma F minus ma equal to 0 according to D'Alembert's principle. That also we can apply. So sigma F equal to ma. So what is sigma F? So sigma F is 150 sine 30 minus FA equal to, I will write it down, that is that gives 150 sine 30 minus 0.2 into 129.9 equal to ma into a. Okay, why I have taken 150 sine 30 as positive? It is because it will be easier if we consider the motion or the motion or the four quantities which are in the direction of motion as positive. So here 150 sine 30 is down the plane parallel to the plane which is in the direction of the motion, or 150 sine 30 is causing the force to move in this direction. So that is taken as positive, all others are taken as negative, that's all. Or if you want, you can take it the other way also, it's okay, no problem. Okay, so 150 sine 30 equal to 150 sine 30 equal to minus 0.2 into 129.9 is equal to ma into aa, where aa is the acceleration of A and ma is the mass of A. Therefore, it is equal to 150 sine 30, where ma is equal to, we can write it as sine 30 minus 0.2 into 129.9 equal to ma is 150 by 9.81 into AA. So from here we will get AA. Directly we will get AA equal to, acceleration of A is equal to 3.9 206 meter per second square. That is the acceleration of block A. Similarly, for block B, this will be angle will be same 30 degree. Therefore, this will be 100 cos 30 and this will be 100 sin 30, the parallel and perpendicular components. Then the reaction RB and the frictional force FB. Frictional force at B, FB. So these are the forces acting on the body B with the weight 100. Okay. So for block B, we will consider as in the block A's case, we will consider perpendicular to the plane. First of all, perpendicular. What will be the condition? Sigma F is equal to 0 because there is no motion perpendicular to the plane. So RB minus 100 cos 30 equal to 0. That will give you RB equal to 100 cos 30, or it is 86.6 Newton. 86.6 Newton. Now we will consider the parallel forces. What are the parallel forces? 100 sin 30 is taken as positive because it is acting in the direction of motion. So 100 sin 30 minus 0.4 into 86.6. What is that? FB. FB is equal to mu k into RB, or mu B into RB. Mu B into RB. Isn't it? So RB is 86.6. We already got it here. So 100 sin 30 minus 0.4 into 86.6 RB equal to MA, equal to MB AB, where MB is the mass of the block B and AB is the acceleration of block B. Acceleration of block B. So that is 100 sin 30 minus 0.4 into 86.6 equal to mass of B is 100 by 9.81 into AB. So from this equation you will get AB equal to acceleration of B equal to 1.51 meter per second square. 1.51 meter per second square will be the acceleration of block B. So acceleration of block A was 3.206 and block B is 1.51 meter per second square. Okay. Now that is the first part to find the accelerations of the bodies. We got the values. Now we need to solve the second part. That is, in what time block B or block A will hit block B. In what time block A will hit block B. So we can assume that at this point when block B reaches this point, block A also reaches the same point. That means there will be a collision. So let x be the distance from the initial position of B to the point where A collides with the B. Okay. So during the say if t is the time required for B to reach this point, In the same t seconds, A will also reach here. Okay. So if t is the time in seconds for B to reach from this initial position to this point, in the same time t, A will reach this point from the initial position, that is from here. Okay. So during that time, t seconds, B will travel. So this is B, this is A. B will travel a distance of x meters and A will be traveling a distance of 15 plus x meters. Is it not? Because initially there was a distance, a difference of, or a distance of 15 meters between A and B. So totally A will travel a distance of 15 plus x in a time of t seconds. Okay. So that is the clue. Now let us consider the motion of B from its initial position to the point where they are colliding. Okay, let the distance travel be SB. So for block B, let the distance travel be SB equal to, we know the equation, UT plus half AT square. Okay, so here it is UB into T plus half into AB into T square, where UB is the initial velocity of block B and AB is the acceleration of block B. Time is same for both A and B to travel, say for B x meters and A 15 plus x meters. Therefore, it is taken as T. Okay, so SB is x. In the case of B, SB is x. Therefore, x equal to UB into T is 0. So, therefore, it is half into A of B is 1.507 into T square. So x equal to half into 1.507 T square. Let this be equation number 1. Then for block A, say in the apply the same equation. SA equal to UA into T plus half AA into T square, because T is same for both A and B, and UA is the initial velocity of A and AA is the acceleration of block A. Here SA, we know the value, it is 15 plus x equal to UA is 0, so this time is 0 because initial velocity is 0. Why? The bodies were released from rest, equal to half into A is, acceleration of A is 3.206 or 3.21 into T square. So let this be equation number 2. Okay, now we have two equations involving x and t as the unknowns. So solving these two equations simultaneously, for t we will get t equal to, how to solve it? Say subtract, or in many ways it can be solved. So t from these two equations, from 1 and 2, t is equal to 4.2 seconds. 4.2 seconds. Okay, so in t seconds, B will travel a distance of x meters and A will travel a distance of 15 plus x, so that they will collide, and the collision point will be here, that is assumed point. Now if you are asked to find out the distance traveled during this time of t seconds, that is 4.2 seconds, you can substitute the value of t in SB and t in SA also to get it. Okay, so the values will be SB is equal to 13.29 meters and SA equal to 28.29 meters. So this will be the distances traveled by A and B during a time period of 4.2 seconds just before they collide each other. So in this case, we have applied both kinetics equations and kinematics equations. So in this case, we applied only kinematics equations. That is, we didn't consider the forces. We consider the forces to find out the acceleration for the second case. Okay, so in the first part, we got the acceleration using the kinetics equation, that is Newton's second law and equilibrium equations. Then here we considered only the kinematics part, that is without considering the force which is causing the motion of the body. Okay.